Hey guys, welcome back to the part two of Project BroadClass. In part one, I had covered system architecture, media suite, creating classroom, going live, recording, etc. features. Now I have added AI layer in the Project BroadClass. So in this video, I am going to cover AI layer, which includes live STD, embeddings, reg, etc. So let's move forward with first of all system architecture. What I have added new services. So yeah, here is the new system architecture of BroadClass. So here you can see that I have added a new AI services. First of all, why I have added a separate AI service instead of in Origin or in Edge. So I don't want that if AI service goes down, then broadcast will be offline. Let's say our AI service goes down because of let's say our DeepGram API, right? Then also broadcast should be online, right? So because of this reason, I have added a separate AI service which is handling all the AI tasks. Now let's move to the our RAG architecture. So this is a RAG flow diagram. Now everything the AI does start with one thing, knowing what the teacher said. So first piece is a live transcription. Now when a broadcast goes live on the origin server, we create a media supplement transport and pull a copy of audio and pipe it through FFmpeg, which convert it to exactly the format that our speech to text engine want. Then we open a WebSocket to our Python AI service and stream that audio on it. Now on the AI service side, that audio frames get streamed into DeepGram Nova 3 for the real-time transcription. And this DeepGram Nova 3 is a multilingual support and auto-detects the language. So teacher can lecture in pretty much any language and it just works. So live transcription part is done. So now row wall of transcript text isn't useful for answering the question. We need to make it searchable by meaning. This is where the rake pipeline begins. So step one is chunking. We don't embed the whole transcript as a block. Instead of that, we split it into a sentence aligned chunk of about 1200 characters with 240 overlap characters between them. And then after step two is embedding. Each chunks get converted into a 384 dimensional vector using a mini LM-L6 model. The nice things here is that this runs locally, so it's completely free. Then step three is storage. We store this vector in PostgreSQL using the PG vector extension. Now let's see the reg Q&A flow. This is the art of the whole project. So let's stress what happened when a student asks a question. So first, as we seen that we had opened the socket. Now, as a student asks a question on the system manager side, we check some basic stuff like rate limit, which is 3 questions per 10 second per user, then access second, and all other basic stuff that we are checking on the system manager side. After that, we embed the question using the same exact model, mini LM model we use for the transcript. Then we run a vector similarity search in PG vector cosine distance and pull back the top 8 most relevant transcript chunk for the specific lecture session. Now after that there is a two-stage answerability gate. Stage one is just chief math. Before we do LLM call, we check is the best matching chunk actually similar enough. For that, we require the top result to have a cosine similarity of at least 0.35 and the average of the top three to be at least 0.30. If we pass stage one, then stage two is a simple LLM itself. We send the retrieved chunk plus the question to the model with this carefully written recruiter system prompt. Now let's say if we not pass stage one, then there is a high chance that question is outside from current lecture. So instead of LLM call, we send that question to the teacher directly. So teacher can answer it verbally or manually by typing and check that question is answered. So this is all about rake flow diagram. And now let's see the demo. So this is a basic dashboard that we have seen in the part one that teacher can create a classroom and share the 6 character code to the student, and in from the student side, student can enter that code and join any class. Now inside classroom, teacher can go live, and of course student can join that live broadcast, and teacher also can record that live broadcast. These are the basic feature. Now if I demonstrate you the AI features, then let's see the demo. Now I will start a lecture for the reg itself. You now just see that how a live transcription is generating and how student is asking a question and AI is giving the answer based on the lecture. Let me start the broadcast. So in today's lecture, we are going to learn retrieval augmented generation. This is an AI framework that improves LLM responses by fetching facts from external base before generating text. It stops AI from hallucinating and allow models to access real-time, private, and domain-specific data without needing an expensive retraining. Now, how RAG works? RAG breaks down the information finding process into four sequential stages. First is the query. You ask a question or provide an AI prompt. Second is retrieval. The system searches external sources to find the most relevant information. Third is augmentation. The retrieved information is combined with the LLM's general knowledge. Then fourth is generation. The LLM construct a response enriched with a factual and verified context. So here you can see that as I asked the question relevant to the current lecture, then our AI assistant give the answer accordingly. And let's say I ask a question outside from today's lecture. So here you can see that this question is sent to the teacher. Now, from the teacher side, you can see that here there is a chat box that can show all the chats asked during this session, and also there is a question queue that this show the question that is not answered by the AI, or basically a question that is not relevant to the current session. So teacher can answer it manually or answer it verbally, and then mark this question as answer. So this is the all about the AI layer in this broad class. Before we wrap up the video, I want to show you one design decision, which is a pluggable multi-provider architecture. Look at this providers folder. Every AI capability like speech to text, embeddings, and answering sits behind a clean interface. I can switch the answer model from Grok's Llama 3.3 to OpenAI's GPT-4 Mini to even Anthropic's Claude Haiku by just changing a single environment variable. No code changes required, right? So this is an good feature for this project. Now, so that's the AI layer for broadcast, live transcription, and grounded reg Q&A assistance. If you found this interesting, drop a comment if you want me to go deeper on any single piece like busy vector setup or the media super audio tapping. Thanks for watching this whole video and see you in the next video.